Welcome back my dear friends and students. A very good morning, good afternoon, good evening to all of you. And this is the DADM, which is Data Analysis and Decision Making course under DADM 1 course under NPTEL MOOC series. And as you know, this course total duration is of 12 weeks, total hours being 30 hours, that is 60 lectures, and each week we have 5 lectures, each being of duration half an hour. And my name is Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you see the slide number is the 56th slide number, that means we are going to start the last week, and in the 11th week we were basically discussing about canonical correlation method, and I was discussing that how you can basically break up these variances depending on the on some set of vectors A, B, C which you choose, such that they are in a way orthogonal to each other, and the amount of variance which you are able to take out or glean from the relationship basically decreases. Decreases means you take out the first set of variance from the first set of relationship and then go accordingly for the second set linear combinations, second set, third set, and so on and so forth. Now, generally in canonical correlation what we need to do is basically given some set of variables or which you can study, we want to find out some other sets of variables such that they as linear relationship, and you also try to decrease the dimensionality of the problem such that the overall dependence is mimicked by minimum number of variables. So, if you have p number of random variables x1 to xp, we will try to basically take q of them, not q out of them, but we will basically try to find out q such variables related in such a way that you are able to mimic the dependent structure to the maximum possible extent. Now, when you want to basically solve the canonical correlation the coefficient method, and I did discuss that you have a set x and then you try to mimic or map it to set y. Set x and set y are the vectors, and you basically form a combinations of taking a vector A and a vector B such that u, which is a function of x, v which is a function of y, have the correlation coefficient in such a way that it mimics whatever was there between A and B. We will try to basically find it out. Now, this canonical correlation method can also be modeled as a simple optimization problem, and this is how it is done. So, from the optimization point of view, canonical correlation method can be stated very simply like this. So, if you have the variance covariance matrix existing between x and y as the summation, and the dimensionality will be maintained here. So, what you want to find out is that we want to find out the covariances or a linear combination of these covariances, where the linear combination is formed by multiplying this variance covariance matrix by A and B, such that you will try to maintain these two, and obviously it will continue if you go stage by stage. That means the correlation coefficient existing or the variance covariance existing between the x's and x's, given you multiply them by A is related to 1, that means you consider the concept of orthogonality to be true, and also you maintained that orthogonality for the set of vector B also, considering for the set of the random variables y. So, we will consider, as I was saying, these vectors A and B would be considered in such a way that the covariances or variances existing between x and x, and that should be related in such a way that when multiplied by vector A, and that is x you are multiplying by vector A, and y you are when you are multiplying by vector B, each is 1. So, what you are trying to do is that you are trying to basically orthogonally break up the relationship. Orthogonal means 90 degrees, such that the relationship between x and y are mimicked by the variances stage by stage, and obviously you will again use the concept of eigenvalues and eigenvectors. So, they broken up into sets such that you will normalize the covariances of x's multiplied linear combination of x's and linear combination of y's to 1 and try to basically maximize the correlation coefficient which is existing between x and y, considering the vectors a and b which are used to form the convex combination of u from x and of v from y. So, let us consider, I am not going to give the details of the data can be found out from the net and the URL is given. So, let me read the problem. Consider the data which is given at University of California, Los Angeles. So, this is under the statistics department and it consists of 600 observations in 8 variables. The psychological variables are locus of control. So, this is a part of the medical studies, self concept or the general concept level which a person has. These 600 observations are pertaining to individuals. The motivation level such that we want to basically have x as considering a matrix of size 600 cross 3, where 600 is the observation pertaining to each of these 3 variables, and is the first set of variables, while the academic variables which are of interest based on which we are going to study, which is basically y, are as follows. Y1 is the reading capability, Y2 is the writing capability, Y3 is the mathematical capability or quantitative capability, Y4, I talked about Y3 and Y4 is basically the scientific acumen capability. So, that these 600 cross 4, which is basically 600 observation for the 4 new variables, is the second set of variables based on which we are trying to model the canonical correlation method. Additionally, the variable female or male which is there. So, as I mentioned, if you remember, there were 8 variables. So, the first 3 are basically x's, next 4 are basically the y's, and the 8th one is basically whether a male or a female one, and obviously we will give the variable values as 0, 1 and 1 or 1 depending on whether the person is a female or a male. So, let me continue reading it. Additionally, the variable female is a 0, 1 indicator variable with 1 indicating a female student, while a 0 denotes a male student. Now, when we solve the canonical correlation method, so obviously you will get these variables a. So, if you remember, we had 3 of these x's. So, x was our size 600 cross 3 or 3 cross 600, whichever way you denote. So, x1, x2, x3 were the variables, and the values of a, which is basically a1, a2, a3, which you will combine with x. So, that means you will try to find out x transpose this variance covariance matrix of. So, I am trying to take the first constraint as this. Similarly, I will change the color, I will have B as forced as subject to constraint as the second one, and based on that we will try to basically maximize the variance covariance matrix, a linear combination of variance covariance matrix between x and y considering a and b as the vectors. So, once we find out a, the values are as given minus 1.2501 till I am reading the first 1 comma 1 value, and the 3 comma 3 value is 1.0935. Similarly, when you find out b using the methods as we have already discussed. So, if you remember, optimization is the other method, but if you remember, we have broken down and found the correlation coefficient step by step and took out the maximum correlation coefficient in the first step, and then basically tried to model the second one considering the orthogonality is maintained. So, we will go step by step. In the second step, we take out the variability to the maximum possible extent, considering it is orthogonal in the first stage, then and also it is basically orthogonal to the later stages which are going to happen. Then we can take out the rho 3's, that means we will find out u3's and v3's such that it will be orthogonal to u2's, v2's, and also be orthogonal to u1's and v1's. So, once we have that, so correspondingly to we find out the A vectors and the B vectors. So, here is basically the B vector. So, obviously, the B vector would be 4 cross 4, because if you remember we have mentioned when we were basically discussing the problem, the number of variables y would is basically 400 cross 6 4 cross 600, where 600 is basically the number of observation which you have. The correlation coefficient maximizations values will be coming as I will only read till the second place of decimal, and there is a reason for that, because and also note down the values. So, how they are decreasing, because that will be applicable as we draw the diagrams. So, the row squares, star squares mean the optimum values are 0.45, 0.15 and 0.02. So, they would basically give you the correlation coefficients of the variability which is there in the first set u1 v1, then second set u2 v2, then third set u3 v3, and continue in this way such that we are able to glean the maximum set of dependence or relationship such that they are orthogonal to each other. Now, we need to find out the new sets of linear combinations of x's, linear combinations of y's, which will give me the actual variability which we want to study. So, if you remember, so this means, and I am reading it, this means that the set of linear combinations of variables which are applicable for our study is based on x1, x2, x3, which were the first set of variables which were of interest to us, but we want to find out the new set of random variables which we think would be a much better way in order to basically study the relationship such that it makes some practical sense. That means, we are trying to basically transform from one coordinate to other coordinate, maintaining the orthogonality and also maintaining the relationship which you want to find out. So, this means the set of linear combination of the variables are given by u1. So, obviously, u1 as I mentioned is a convex combination of a and x. So, a's we have already found out. So, a's, if you remember, they would be a1, a2, a3 depending on the rows. So, a technically a is basically a vector of 3 cross 3. So, the values of a1 would be, if you concentrate on the first row, it will be minus 1.2501, 0.2367 and minus 1.2491. So, that will be multiplied by the vector column vector of x1, x2, x3, and the first u1 is basically given by this linear combinations of x's. I am utilizing the a's. The second set are given, I will use a lighter shade. The second set means corresponding to y's. So, the v1s are given where you multiplied the first rows of b's with the corresponding y values. So, y, if you remember, there are 4 variables, the mathematical speed, the science concept and all these things. So, once we have that, we have the v1 as given. So, just note down the u1 and v1 are given, they are the linear combinations such that we basically get the maximum variability. So, the maximum variability, if you remember, we have mentioned, please note the row star squares. So, 0.44 and all these values, they would become important later on when we study. Then after finding out the orthogonality in the first step, you basically go into the next step where orthogonality is maintained, variability is maximum is gleaned out depending on the fact that we find out the relation to the maximum degrees possible. Then we need to find out the new set of linear combinations of x's, which is basically u2, and linear combination of y vectors, which is basically v2, provided that we have basically the informations of vector a2 and vector b2. So, these vectors a2 and b2, as you know, are given. I am not going to highlight, I am just going to mark it, is 0.766, 0.842, minus 2.636. I am only reading the first 3 places of decimal. When multiplied by x1, x2, x3, which are the random variables based on which you are doing the studies, the second set would be given as minus 7.66 x1 plus 7.66 x1 plus 8.4 x2 minus 2.63 x3. Similarly, when we find out the linear combinations of b's and b2s and y, the second set of v2 which is formed by the combination of b and y comes out like this, minus 0.0016 y 1 minus 0.0904 y 2 minus 0.0030 y 3 plus 0.1242 y 4. So, there are 4 variables here. Finally, we go into u 3 and v 3. u 3 again is found out by multiplying the vector a 3 and x, and the values comes out to be as this, minus, as which I have highlighted, minus 0.4967 x 1 plus 1.2051 x 2 plus 1.0935 x 3, and the values of y v 3 which are found out utilizing the convex combinations of b and we are going to multiply b with y's. So, that is b 3 into the y vector. So, that comes out to be, we will use the color as we are utilizing, it comes out to be 0.0883 y 1 minus 0.0961 y 2 minus 0.0878 y 3 minus 0.0885 y 4. Now, comes the main part. The corresponding linear combinations which you have found out, that means the set u 1 u 1 v 1, set u 2 v 2 and set u 3 v 3, because we are trying to find out the orthogonality, at the same time trying to find out the maximum variability which is taken out at each stage. So, concentrate on what is written. We will denote the sets of u 1 v 1, the points, as blue dots. So, obviously, you will have different sets of points u 1 v 1, u 2 v 2, u 3 v 3 depending on x 1 x 1 y 1, x 2 y 2, x 3 y 3, and they x 1 y 1, x 2 y 2, x 3 y 3 is basically you are trying to find out in each step. It not that you are only going to utilize x 1 for u 1 or x 2 for u 2, only you are going to basically concentrate on the vectors a 1 b 1 for u 1 v 1, a 2 for a 2 and b 2 for u 2 v 2, a 3 b 3 for u 3 v 3. So, based on that I find out the combination and denote it for our simplicity of understanding as u 1 v 1 with blue dots, u 2 v 2 as green dots and u 3 v 3 are red dots, and then try to basically analyze how we draw the diagram. If you remember, I did mention that when the row star square were being written down, I mentioned please note the values, they are in the decreasing order 0.44 until the last value of 0.02. So, though not very apparent, and let me continue reading it in this slide as is given, though not very apparent, one can easily discern or see that the value of the correlation coefficients or the slope of the set of the blue plots are maximum, followed by the green plots which is second, followed by the red plots which is the third, which means that you are trying to slowly divide the, I am repeating these words time and again, please bear with me. We are trying to basically find out the relationship step by step such that the correlation is basically mimicked stage by stage, maintaining orthogonality and trying to take out the maximum correlation coefficient at first stage, then second stage and third stage as depicted by the correlation coefficient values, which is rho star square. So, this is the correlation coefficient values. So, correlation coefficient values would basically be if you remember, I did discuss if I am not wrong in the first I think in the within the third or fourth week of this course, that how would you basically understand the correlation coefficients being between -1 and +1, and they can be ranges between -1 to 0, the value of 0 and the value of 0 to +1. So, I will again draw it and then basically try to compare the analysis which I am going to do with the diagrams which is there. So, please give me 1 minute, I will basically add one slides for a better understanding. So, this is the slide which I have added, the blank one, with respect to the correlation coefficient concept which I am going to explain for the u 1 v 1 combinations, linear combinations of x and y's which are coming out by multiplying a with x vector, B with y vector, A and B being A1 and B1. Then we find out u2 v2 by multiplying A2 with x, B2 with y. Then we find out u3 v3, which is basically multiplying A3 with x and B3 with y. Now, I said that the correlation coefficient of this green, red and blue and were basically giving us the information as the numerical value of rho square star vector was, that how the correlation coefficient changes. So, and then I said that we had discussed these problems when we are doing correlation coefficient. I will try to draw it within this diagram. So, let me draw it. So, consider this is the relationship between x1 and y1 or x1 and x2, these are random variables. So, let me denote by x1, x2. So, consider they are positive correlated and correlation is basically between greater than 0 and less than equal to 1. So, let me use the red points. So, they would be scattered in this way. So, the whole set would be like this and the tan of this angle theta. So, the best fit would be positive. Now, if I go for the, so make a note of this, if I go to the value where correlation coefficient is in and around 0. So, in the first graph the red one we saw they were positive, they were in the first and the third quadrant. If they were 0, again I plot x1, I plot x2 and how the correlation coefficient would be scattered for the correlation values being between almost in and around 0. So, they would be basically on all the 4 quadrants. So, there would not be any best fit line. Finally, I will not discard it, I will erase it and draw it for the, oh sorry, my mistake, I will draw it for the negative one also. You have seen it, then I will come to the. So, once I have for negative values, this is x1, this is x2 and I will not use this. So, it is negative so it would be tan would be in the negative direction. So, it is in the second and the fourth quadrant. So, in the first case when it was the red one, correlation coefficient was positive, that is why I am using the red color. When it was in the, so correlation is almost equal to 0 for the second case, and for the third case correlation is less than 0. So, obviously, as we know the correlation coefficient is always between -1 into +1. So, now with this if you come to this diagram it will make sense. So, if you see the correlation for the red one and the green one are almost tending towards 0, while the blue one is positive. And if you note down, I am first time I am just going again in the front to the slides. So, you see the blue, green and the red are in the order where blue has the highest, green second and the red the third. So, that means u1 v1, u2 v2, u3 v3. So, blue set if you see, I will just use the highlighter. So, it is the maximum set is here, and if you see the green one, they are less steep slope, and the red one is always almost equal to 0. So, they have broken down the correlation into 3 sets depending on the maximization concept. You are trying to maximize the covariance, linear combination of the covariance depending on some values of A and B, and you force the concepts of the linear combinations of A's to 1 with x and B's to 1 with y, and solve the problem. Now, if you remember, I did show the correlation coefficient vector almost at the beginning, and I did mention the values were, please note down, I noted out, they are in the decreasing order. So, these values are 0.44, I will only read till the second place, 0.44, 0.15, 0.02. So, these correlations are you are trying to find out by the combinations of u1 v1, then u2 v2 and u3 v3 depending on the fact you can glean accordingly. Now, you want to verify this task which you have done, that means you have broken down the correlation coefficient and try to basically get the maximum set of information. So, another way of verifying the values of rho 1 square, rho 2 square and rho 3 square is to have a look at the covariances u v. So, if you find out the covariances of u v, they are if you those 0.44 values. So, here is basically in the first box, so called box which I have formulated, you have the rho 1 values. If you go to the second one, so this is the correlation coefficient for the second stage, rho 2 square, and the third one I will try highlight is the blue one. This is the third values which I have. So, I have found out or delineated rho 1 square, rho 2 square and rho 3 square depending on the covariance of u and v. So, u and v are, if you remember, u is basically a matrix depending on x and a combinations, and x being of 600 cross 3, 600 is basically the random samples numbers of observation, and y being of 600 cross 4. Hence, obviously, if you count the values 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 depending on the combinations we have been able to form for u and v. So, with this I will close this 56th lecture and continue the last remaining 4, 57, 58, 59, 60 depending on correlation coefficient concept and some other concept of multivariate statistical analysis. Have a nice day and thank you very much.